Okay, I just want to go over a couple of these calculations to get you off to the right start. Um, Looking at the left-hand column, these are common things you'll need to calculate. Of course, your computer system usually calculates these for you, but sometimes you might notice something doesn't look right, and you should always double check those calculations by hand if you feel something is off. So common ones are time in bread, and there I've given you the abbreviation TIB, and it is going to be important that you recognize these abbreviations. The calculation for time in bed is the lights on epoch minus the lights out epoch divided by 2. So if a study went to epoch 961 and the study started on epoch 1, you'd subtract that, divide it by 2, and you get the total amount of time in bed. Now, why would we want that? Well, because time in bed does not mean time asleep. So it is important to differentiate how much time were they actually in bed versus how much of that time were they asleep. So our next calculation down is total sleep time, abbreviated TST, and this is the total epochs of all the stages of sleep divided by 2. So it's N1 sleep, N2 sleep, N3 sleep, and R. Add up all those numbers and then divide it by 2. There is an alternative calculation, which is the time in bed times 2, and then subtract out the total amount of awake epochs, and then divide that by 2. Why anybody would ever use that calculation is beyond me, to be honest, but better to have it and be aware it exists. So there I have an example for you. In the example, the patient had 192 epochs scored as stage N1. They had 480 epochs scored as N2, 84 epochs scored as N3, and 164 epochs scored as REM. Then divided that total number by 2, and the patient spent 460 minutes asleep. Moving on down, the sleep latency or sleep onset is abbreviated SL. We discussed this in one of our previous videos. It's the first epoch scored as something other than awake minus the lights out epoch divided by 2. And there's an example for you. Moving on to REM latency. There is no abbreviation for this. It's the first epoch scored as R minus the first epoch scored as something other than W. Then divide that number by 2. So we're taking the first epoch of REM sleep and subtracting the first epoch of sleep or your sleep onset, and then divide that by 2. So here in the example, we have that the patient went into REM sleep at epoch 221 minus epoch 41, where the patient first fell asleep. Divide that by 2 for a REM latency of 90 minutes, and that is about a normal REM latency, anywhere from 60 to 90 minutes. Moving down the table, percent total wake time, abbreviated percent W. This is the total time of wake divided by the time in bed times 100. So you take your total amount of wake time in minutes. So if you have it in epochs, you have to divide it by 2 to get it into minutes. So in the example, I have 20 minutes of awake divided by the time in bed, which is 480, and then take that times 100 to get a percent, and we get 4.17%. Now notice we use time in bed for wake. Now let's go down to the next row where we have the percent of sleep stages. And I have the abbreviations there for you. And so with the calculation, it's same as the one for wake, only instead of using time in bed, we're using total sleep time. So let's do stage N1 as an example. So in one of our prior calculations, we had 192 epochs of stage N1. If we divide that by 2, we get 96 minutes. So 96 minutes of stage N1 divided by the total sleep time, which was 460 minutes. Take that times 100 and we get 20.87%. That is a little bit high of a percentage for stage N1 sleep. Okay, moving down our table, the apnea-hypopnea index, abbreviated AHI. You take the number of all apneas and the number of all hypopneas, divide it by your total sleep time, and then you take that times 60, because we want is how many times did they stop breathing or did they abnormally breathe per hour of sleep. So that's where the 60 comes in, 60 minutes in an hour. So let's say the patient had 80 obstructive apneas and 90 hypopneas. We would add those together, divide it by 460, and then take it times 60, and we would get 22 events per hour of sleep. And we use the term events because we know that it's not all apneas and it's not all hypopneas, so it's a combination, so we just call them events. Going down to our next row, this just explains that we could use anything to create an index. We could do a central apnea index, a PLM index, a RERA index. It doesn't matter what it is, it's the same calculation. So it's the total number of that specific type of event divided by total sleep time times 60. Okay, our very last calculation is sleep efficiency. It's abbreviated SE. We have talked about this back in fundamentals. A normal sleep efficiency is 85% or greater. And this is where we take the total sleep time in minutes divided by the time in bed in minutes times 100. So the example here is 460 divided by 480 times 100 for a 95.83% sleep efficiency. This person sleeps awesome. So, all right, that's the end of this.